Good morning, everyone. My name is Ken. I work for AWS Professional Services, and I am very excited to be here to talk about running big data analytics on AWS with you. And we are very fortunate to have Natalie, who is from FWD Group, to share the story of her organization and her team embarking on this big data journey on AWS. Now, if we look at insurance companies across the globe, there are a lot of companies that are collecting a lot of data already. There are also heaps of potentials this company can leverage the data to really forge the competitive advantages among their peers in the vertical. One of the examples they can do with data is to really uplift and revamp the customer experience. Let me give you one example. You pick up the phone, you call the help desk of the insurance company, and you'll be put on hold, listening to the waiting music and being told, your call is important to us, we will get to you as soon as possible, repetitively. Okay, the alternative can be, you can be talking to a chatbot that's available 24/7, it's powered by the AI and the data, and often the chatbot can answer a query you're going there for, but even when the chatbot cannot do so, when a human operator picks up the phone, the human operator can have the case context of what's going on and a profile by you. So the human operator doesn't have to ask any relevant questions. Now that's refreshing customer experience. Another thing these companies can do with data is to really drive the product innovation. So every time a company decides to move into the new field, to have a new coverage, new policy, it is essentially a data-driven decision-making. Having a mature data capability can help you to increase the accuracy of that decision-making process, so you can confidently move into a new field such as cyber insurance, such as drone insurance. And at the same time, it can help to improve your existing products as well, especially those short-term based products such as travel insurance and event-based insurance. I personally have heard one of the insurers giving out variable premium on the motor vehicle policies. This is how it works. So they give the sensors out to their customers where they can install in their cars. And the sensor will then try to pick up telemetry, send all the way back to the insurance company where they can do the data crunching to understand the driving patterns, driving behaviors, etc. So the insurance company can then reward those safer drivers and penalize those risky drivers at the same time. In the long run, they were trying to change the behavior from the risky drivers to safer drivers. Now that is really good. Talking about insurance company, there is a provision called incurred but not reported. How much money do you put into this provision? And often the calculation is done by the models, the algorithms, etc. Having a great data capability can really help you increase the accuracy of the calculation as well. By setting aside the right amount of money in the provision, in return you will have a better financial agility, but also better cash flow. Now let's talk about claims. Claims is often one of those make or break experience for customers when it comes to insurance. What we have seen across the board is a lot of insurance companies are moving away from those manual claim processes to automated data-driven and AI-driven claim processes. The focus really is to reduce the amount of time from people lodging a claim to having the outcome to finally being paid out. And also because of this change, the amount of money and effort that goes into detecting the claim fraud actually goes down, whereas the accuracy of the fraud detection goes up as well. Now, last but not least, having great data program and great data capability can really help you to uplift your overall risk management capability as well. In the insurance industry, as we know, almost everything is tied into risks. So having better risk management capability can really help you to drive your overall portfolio profitability. Okay, there has been a lot of potentials and great stuff we can do with data. Let's look at some of the common challenges insurance companies may have today if you are hosting your data infrastructure on-premise. One of the first things come to mind is scalability issues. As we talked about before, you are producing huge amount of data every day, and that's a requirement to capture those data and store this data securely at the same time as well. So your on-premise infrastructure usually doesn't provide you such capability to do so. What you normally do is trying to predict what the capacity looks like at the peak, and you over-provision. And as a result, you have to cost a lot of money, and you have to incur a lot of excessive cost and expense to manage those infrastructure. And at the same time, you have a lower utilization of your asset and lower return on your asset as well. Another issue insurance companies normally have is data in the silos or fragmentations. The biggest challenges for data in silo is it is very difficult for you to cross-referencing data if they are in the different silos. And it is also very likely that in each silo, you are running completely different ETL processes, which will then finally driving down overall data quality, which makes your end user, your business user, very difficult to extract any useful insight out of this data set. A lot of insurance companies are running data warehouse today. For data warehouse, you have to really prepare the data to be very rigorous data schema and format, etc., so you can ingest them into a data warehouse. Now, that is very good and effective for data warehouse kind of workload, but it really takes away the flexibility for you to use the same data set for other types of analytics solutions. And think about another scenario as well. If you have a new data set comes in, it will take you some time to really prepare this data so you can do the ingestion. Now, all the lead time for data preparation will actually add up, which will really slow down your overall data program. Lastly, it is a constant battle for insurance companies to making sure how much data they have to make online, how much data they have to make offline. By online, what it means is making the data immediately available for the users and applications. But making data online can be very, very expensive. So these companies will look at off-site, some tape-based archival solutions. But that comes with shortcoming as well. Every time, if you like to access this data from off-site facilities, it will take you days, if not weeks. So the answer is data lake in the cloud. So what data lake is, it is essentially a centralized repository for all sorts of data you have today, from structured data to unstructured data, from relational data to non-relational data. You can capture those data and store them at the same format when they were produced and being captured. You don't have to have the question and answer on what sort of workload, what sort of use case I need to do with this data at a point in time. You just need to collect them and put them into the wrong place and making sure you can access the data to well-defined interfaces. Now, a lot of people ask the question, are you advocating building the data lake but get rid of my existing data warehouse solution, which I spent a lot of money and effort to build? Not quite so. What we have seen is a lot of companies are actually using data lake to complement the existing data warehouse solution. As we talked about before, data lake allows you to store any types of data, so you can really easily convert those data into the defined format that you can do the ingestion in your data warehouse as well. Now, lastly, you can also choose to archive your data in the data lake. But instead of waiting for days or weeks, it will be minutes, if not just seconds. So, data lake in AWS. The center of the universe for data lake in AWS is S3. Now, being S3, it comes with best-in-class security, compliance, and audit capabilities. But also, it comes with unmatched durability, availability, and scalability. But what I want to do now is to draw your attention to some of the S3's unique features. One of them is S3 Object Lock. Imagine you have to store and process some of the very regulated data, and having the S3 Object Lock can provide you the confidence for data integrity. So once your data is written into the data lake, you have the confidence that it will never be altered or deleted. And at the same time, you're able to compose one of those write once but read many types of policies in a matter of minutes, which further eased an administrative effort required to manage and analyze those types of data as well. Another feature is S3 Intelligent Tiering. So what Intelligent Tiering does is you will automatically move your data objects from frequently accessed tier to infrequently accessed tier based on the pattern of how your objects being accessed. So S3 being a very economical storage solution already, having an intelligent tiering can help you further drive down the cost, to optimize the cost across your entire data lake. In AWS, what we want to do is provide you most comprehensive, scalable, cost-effective, and secure offerings that you can pick and choose to build a data lake. And at the same time, we want to provide you different types of analytics options where you can run your traditional SQLite queries, but also machine learning and deep learning of your data. We understand there is no silver bullet to solve all of your analytics problems, but what we want to do is provide you the right tooling to do the right job at any stage of your analytics lifecycle, from collection of data, transferring of data, storage of data, to analytics and machine learning of data. There should always be something for you, either natively from our platform or from our partner networks as well. This is a diagram really illustrates the ecosystem of big data platform in AWS. As you can tell, you can really stream and import any type of data you have today. Should that be structured data that's produced by your ERP, CRM, or lines of business applications, or semi-structured data that can be your mobile application or social media feeds, or completely unstructured data that can be phone call recordings or images that's uploaded by your customers. Now, depending on the attributes of data, how they have been captured, and how quickly you like to process and analyze and extract insight out of this data, you can choose to bring the data into data lake using different type of methods, such as batch uploading or real-time streaming. Now, once you get your data into data lake, then you can then plug in different types of analytics. Like we talked about before, you can choose to run your traditional SQL-like analytics using Athena, which is a serverless solution, or you can also run your big data on your data warehouse using Redshift. You can also run your business intelligence using QuickSight. At the same time, you still have the option to run your machine learning, but also deep learning using some of our purposely built Amazon machine deep learning, Amazon machine images. Okay, before we go into some of the architectural patterns, we like to go to some of the principles first. The first principle is really to build your decoupled system. This is the principle that's not exclusive to data type of workload, but the underlying message is exactly the same. We would like you to build your system to be not having any dependency upstream or downstream. The second principle is to choose to use the right tooling to do the right job. But over here, what we're advocating is for you to think backwards. Think about what sort of outcome and objective you're trying to realize. Then think about what sort of data set can really help you to realize those outcomes. But think about what sort of tooling can help you to capture, store, and analyze those data as well. Now, the third principle is to use managed and serverless solutions as possible. The rationale is quite simple. We want you to focus on what matters the most, but give away those undifferentiated heavy lifting to AWS, so you can really invest your energy, scarce resources into data workload. Now, the fourth principle is embarking on the event journaling kind of design pattern. So instead of writing the data and overwriting the data in the data lake, what you want to do is to append into the data set. In a scenario where you have a large data set and one of your ETL services accidentally corrupted the data, you can always revert to the previous version of data, so you won't have any data loss. Now, the fifth principle is to be cost savvy and cost conscious. Running big data doesn't mean have to cost you a lot of money. With managed and serverless solutions and some of the features we talked about, such as S3 intelligent tiering, can really help you to further optimize the cost structure of your entire data lake. The last principle is to think about machine learning. Our prediction is in the future, almost everything is infused with machine learning. And we have seen a lot of insurance companies are working on machine learning initiatives as well. So you should do the same thing. Okay, now first few steps for data analytics in the cloud is to get data into the cloud. So we'll be going to 2 batch upload ingestion patterns and 1 real-time streaming ingestion pattern. If you're running Hadoop type workload today, and you'll be very familiar with this pattern over here, but instead of having to manage the compute and the storage of Hadoop, you can give that EMR. So EMR is essentially a managed Hadoop cluster. For instance, you can stand up one EMR ingestion cluster and use Apache Scoop to grab the data from your relational database on-premise and put into the raw tier of your data lake. And then from there, you can process the data, put the data into the processor tier as temporary storage, where you can apply business logic, flattening the files, and enriching data, etc., and put data in the consumption tier, where you can stand up another EMR analytics cluster to do the further analytics of the data to extract insight. As your data traverses into different tiers, you can use the Hive table to do the data cataloging as well. Now, you also have the ability to produce and present those insights using the QuickSight to your downstream business users as well. Okay, this is the second pattern, batch ingestion pattern, but this time, instead of using EMR, we're using Amazon Glue. So what Amazon Glue is, it is essentially a managed, again, but also serverless solution. At the previous places where you're using EMR to process the data and transform the data and move the data, you can use Amazon Glue. And at the previous place you use the Hive table to do the data cataloging, you can use Glue Data Catalog. Now once your data gets into the consumption tier, you can choose to run ad hoc SQL-like analytics using Amazon Athena. You can run data warehouse using Amazon Redshift. We also have a new service, it is called Amazon Redshift Spectrum, which allows you to run SQL-like query across your Redshift clusters, but also S3 bucket. That is fantastic. But also you have the choice to present those insights to your business users using QuickSight. Okay, this last pattern is the real-time streaming pattern. The hero here is Kinesis. You can use Kinesis data stream to really streaming data from IoT devices or logs from your desktops, laptops, and mobile devices into your data lake for some of those non-real-time workloads, non-real-time data analytics use cases. But at the same time, as we know, the streaming data is losing its value every second if you don't produce, if you don't process and analyze them. So give you the ability to really extract the actionable insight out of the streaming data using Kinesis data analytics. So you can choose to produce those actionable insight and store them in the data DynamoDB, and also push those actionable insight to your end users in the real time. Okay, I think it's probably enough talking from me today. I would like to give the stage to Natalie, who's from FWD Group, to share the story of how her team built this big data solution on AWS. Thank you.
Hi, everyone. I'm excited to be here on stage today, especially since a few years back I was working at Amazon in London. My background is actually from the tech world. I worked at a few tech startups as well as large tech companies. In those companies, first-handedly, I saw how quickly we were able to build and release new features, to scale to millions of customers, and be able to enter new markets and disrupt different industries. My goal at FWD, after joining, has been bringing the same type of approach, how we innovated in the tech world, to the insurance area, and see how we can find ways to serve our customers better. FWD Insurance is a dynamic insurer with presence with 9 countries across Asia Pacific. We started only 5 years ago and now have more than 3 million customers and $28 billion in assets. When FWD was started, there were many large insurance on the market, but we had a vision that there are many ways we can improve and serve our customers better than currently existed on the market by creating better customer experience, reducing price, improving purchasing and servicing flows, and becoming a customer-obsessed company than compared to the traditional insurance companies. We've made insurance as simple as possible by creating comprehensive products, removing agents and commissions, especially in our Singapore market, giving the savings back to our customers, simplifying the claims functionality, improving the underwriting UI, and making the website as easy to use as any e-commerce platform website. FWD chose to focus on leveraging technology as a foundation to do things differently. And of course, key area to any tech platform is data and analytics. For our data lake project, when we were deciding which approach to choose, of course, we took a look at the traditional on-premise approach, where we set up our own data servers to store the customer data. The reason why we took a look at the traditional approach, because it is a very common practice in the insurance space. However, to build the customer experience and to achieve the speed to market that we wanted to enable, that would not have worked for us, mainly because we would have to buy quite a few new servers, get them all set up, hire additional infrastructure team. And because we wanted to go with the iterative release for the data lake, that would have cost us quite a lot of upfront investment that wouldn't be used at the beginning. So we chose not to go ahead with that approach. In collaboration with our data and analytics partner, BigTab, we chose for our data lake to go ahead with AWS for very clear reasons. So first of all, effortless scalability, elastic nature to accommodate our iterative data lake releases, self-service infrastructure, ease of collaboration and access of data across different internal teams. And then on top of that, having access to hundreds of AWS services that we continue to leverage on a daily basis to continue building the customer value and simplifying our processes. For example, one of the use cases that we like to bring is when we started in the in Singapore market to buy a car insurance, customers would have to answer 27 pages of questions in order to get a car insurance. We simplified that process to only 10 questions where we ask basic information that we need, and then rest we leveraging the technology to underwrite the customer, therefore improving the experience and returning lots of time back to our customers. An important part for me as well, when selecting the tech stack to work with, is hiring the best talent. I prefer to hire people from the tech industry, as well as other industries, who are digital natives. And I do not know a single digital native who wants to work with the legacy tech stacks that are hard to deploy and having to wait weeks and months to launch the features that they build for the customers. So for my team, that was very essential to use a platform that we can easily build on and move quickly. So let me share a little bit how we went through our data lake project building. So as I mentioned, we looked into 3 phases. We deployed the phase 1 in December. And now we have 5 of our main sources of data inside the S3 data lake that we can query using Athena. Initial work, when to get started, we had to understand all the legal and compliance requirements, which took a bit of time, and rightfully so, because it is very important for us to make sure we protect and use our data accurately. So that took a few months for us to complete. Afterwards, to get going with the AWS account setup was quite easy, and get moving with implementation was also a smooth process. After the data lake was released, what it enabled us to do, we were able to link previously not connected data sources, such as data files, such as claim images, quotes, because we have both life insurance products and general insurance products, combining those two, looking at the claims, call center logs, and much more. Utilizing this data, we are now able to automate some of the claims processing and expedite how quickly we process our customers' claims. In some cases, going from a couple days, in some cases to in the same day processing, utilizing AI, and of course utilizing the data that we have created. Using data lake approach, we are also able to digitize and store some of our historical unstructured data. And again, this information, this data, we are able to use to simplify even further the underwriting, the purchasing flow, with the goal to serve our customers better, and with the goal to simplify insurance even further. In addition to Singapore, we are actually looking at utilizing AWS service in other countries. For example, in Thailand, our Thailand team was able to build external facing services to be consumed by our bancassurance distribution partners. This approach enabled them to scale by shielding on-prem services from too much traffic. Security compliant and DevOps are the tools that they used and were essential for them to move quickly during the partner integration. In my role, I oversee all of the 9 markets for FWD, and building the data lake in the cloud in Singapore and using AWS services was a good starting point for us, especially because for my team, for the innovation projects, we are running multiple AWS services to again experiment and try all the new features that we can roll out to other markets. One of the examples, we recently released a chatbot in Singapore. this chatbot is the first chatbot on the market that enables customers to file claims, travel claims directly via the chatbot. It can be accessed anywhere, anytime, and just takes a couple minutes to file the claim. We were able to train the bot, scale it to more traffic, as well as to additional platforms without any need to set up new servers. Actually, most of the innovation projects now are being set on AWS. This enables us to move quickly, as well as to work on multiple projects at the same time. The most common services we use are S3 buckets, EC2 instances, and then, of course, we API Gateway, Lambda, DynamoDB, as well as experimenting with some of the machine learning services, such as Amazon Comprehend, Lex. All these tools enables my team to move faster and to serve our customers better. To close, in the recent Business Times article on innovation, most leaders across different industries stated that having best-in-class technology is a foundation for staying ahead. To create a culture of innovation, we have to give our employees, our teams, the best tools to build the value-added experiences and to continue to improve how we serve our customers. Amazon Web Services set of solutions is one of the foundational components that help FWD to build high customer value and to continue innovating. Thank you.